All right. In this talk, I will discuss a general form of expected SARSA, which has actually gained not very much attention since it was created in 2011. So I will focus on its flexibility and hopefully open a discussion about how we might actually use its flexibility. So all the algorithms I will be presenting today are in the table lookup case with one-step learning. And I will begin the presentation with some background information. So we formulate our problem as an MDP, where an agent takes action according to the policy pi and interacts with the world, transitions from state to states, obtaining numerical rewards. So in reinforcement learning control, there has been two methods that can solve the MDP. One is SARSA, and the other one is Qlearning. SARSA is an on-policy control because it behaves according to the same policy that it is also evaluating. Thus, SARSA's behavior policy mu equals the policy pi, the policy that is also evaluating. Qlearning, on the other hand, is an off-policy control because its behavior is according to mu, but at the same time evaluating a greedy policy that's due to the maximization. A less well-known control algorithm is the expected SARSA, first mentioned in Rich and Andrews' 1988 textbook as only an exercise. If we examine the target of the action value update, we see that the target pi need not be the same as the behavior policy mu. Thus, we can set up the expected SARSA to be on policy or off policy. When it's on policy, the mu would just equals to pi in this case. But we don't want to stop just there to generalize. We want to be even more general, is if we actually don't fix the target policy. We allow it to vary from time step to time step. And now we would have a sequence of policies that replace a single fixed policy pi, and a sequence of policies that replace a single fixed policy mu. It's like, why not? We can do this. So general expected SARSA in this form really reduces back to SARSA if the state and action pair, the AT+1 and ST+1, were sampled according to the policy, behavior policy mu t for that same state and action pair. And then if we set the pi of that state and action pair to 1, we actually reduce this back to SARSA. And for Qlearning, is that if we choose the pi t to be greedy with respect to qt, we get Qlearning. And general expected SARSA is more general than SARSA and Qlearning, because if you examine the update for SARSA, SARSA evaluates a policy that is also following, which actually bounds the action values to also its behavior. This is rather inflexible because SARSA forces us to choose an action of the next state so that we can make an update of the action value, but then we're also forced to commit to that action in the next time step. The action value updates and the behavior of the agents are not separate in this case. Expected SARSA, on the other hand, can be used in an off-policy setting, where it is not restricted to the behavior policy for the update of the action value. The behavior can be something arbitrary while evaluating a target policy of interest. Qlearning, on the other hand, allows for the agent to behave according to a policy that is different than what it is actually evaluating. Hence, there's a separation between the action value updates and the behavior, but the update requires a maximization with respect to the action values of the next state. While expected SARSA, on the other hand, is not limited to maximization. I can always place a non-zero probability over all the actions of the next state. Thus, it gives that generality and also flexibility. So all in all, general expected SARSA separates the action value updates and the agent's behavior. This means that the agents can behave in a very exploratory way while learning something different. It also provides us the flexibility of choosing a target policy that is not necessarily greedy with respect to the action values. Okay. The idea of actually not fixing the target policy and behavior policy has actually been around for a while. But I haven't seen much of use of this algorithm in this kind of setting. So general expected SARSA was actually first mentioned in Hado's PhD thesis in 2011, or actually 2010, sorry. He called it general Qlearning. The reason I did not use his terminology is because I don't want to draw the attention to the maximization over the actions of the next day. I want to draw our attention to the expectation over the actions of the next day. And in general Qlearning, it's actually proven to be convergent to the optimal policy for any combination of behavior and target policies, as long as the behavior policy results in infinite exploration and target policy is greedy in the limit. So what I mean by infinite exploration in this case is that we mean that the state and action pairs are visited infinitely often. And by greedy, we mean that the policy always chooses the action that is associated with the largest action values. Okay, and here are some suggestions on what we can make the target policy greedy. So the first one is if we use a epsilon t greedy policy with a sequence of non-increasing epsilon t. So in this case, we could just pick a sequence of epsilon t that's decaying to 0. And I can choose a sequence of pi t to be epsilon t away from the greedy policy pi qt. So this pi qt is actually is a greedy policy with respect to the action values. So this is one way of making the target policy, potentially making the target policy greedy. And the other way is we could use the softmax policies with non-decreasing temperature, where the temperature beta t is the temperature and then decay it to 0. And there's other more complicated methods by Perkins and Prekop in their 2002 paper, where that could also maybe perhaps used in this scenario. But making the target policy greedy gave us a sequence of changing target policies, but really, should the target policy only be made greedy in the limit? Is this the only way? So for example, what if we have a world that stays stationary for some periods of time and then changes? So the agent learns the optimal action values for the duration when the world is changing, when the world is stationary. But when the world changes, the learning would benefit from target policies that probably are more exploratory, rather than being more greedy with respect to the last world's target policy, optimal action values. But the other example, perhaps is more convincing, is if we use when we have multiple objectives, where we need to make optimal decisions based on trade-offs between two or more conflicting objectives, with constraints on what combinations of those objectives are attainable. For instance, in self-driving car, what if we want to minimize the risk of an accident while maximizing driving experience? When buying a house, what if we want to minimize the cost, the noise of the streets, while maximizing the square footage and close-by amenities? These are all conflicting objectives. In economics, consumers' demand for various merchandise is determined by maximizing utilities derived from those merchandises, subject to constraints based on how much income is available to spend on those merchandise and on prices of those merchandise. Ideally, we would like to consume more of each merchandise, but given limited resources, we can only allow more of one merchandise. We can allow more of one merchandise while sacrificing consuming less of other merchandise. So the various objectives are in conflict with each other in that sense. So, and this is true in many real world situations, and we cannot just minimize or maximize all the objectives all at once without degrading some other objectives. So being greedy in this sense cannot really quite capture this. Okay, so those are some things I would like to think about as how to actually come up with a target policy pi t in this case. So in conclusion, I want to say is general expected SARSA is more flexible than SARSA and Qlearning. And general expected SARSA would merit more research in this area. And we would like to principally exploit its flexibility and perhaps one day convince the community to use general expected SARSA instead of Qlearning. We think that perhaps combining maybe policy search methods with the general expected SARSA can be a powerful method to achieve better overall decision making. Okay, so since we have time, how much time did I have? How much time do I have left? Huh? Okay, so I've only 10 minutes. So there's one last point I want to bring to attention. Is what is actually happening with the general expected SARSA? So this was the second thing I kind of want to think about. Is actually general SARSA bridging between policy iteration and value iteration? Okay, so here we have two dynamic programming methods that solve the MDP, two very, very classic paradigms, policy iteration and value iteration. So on one side, policy iteration evaluates a policy for some number of iterations, and then we improve the policy with respect to the action values. Okay, in value iteration, the evaluation stops after just one update of each state. And value iteration combines both the policy improvement and the policy evaluation in one update of the values. So while policy iteration has the evaluation and policy improvement divided into two distinct stages, value iteration effectively kind of mixes the two. So, and we can see the SARSA is sort of the stochastic version of, policy iteration, at least the evaluation part. And the Qlearning is some stochastic version of value iteration. But then, general expected SARSA maybe doing something between the two, doing something maybe as between the policy iteration or value iteration. Because, for instance, we can fix the pi t and evaluate pi t for some number of iterations, and then come up with a new policy based on the action values, and evaluate the improved policy for some number of iterations, and repeat the process again and again until the policy is stable. This would be similar to policy iteration. Or we can just improve the pi t with respect to the action values after every time step. And even maybe using more, greedier policies like, how the Qlearning is. But which is, in that sense would be very similar to value iteration. So then with the expected SARSA, general expected SARSA, come into the picture, is there maybe policy iteration, value iteration could be generalized in some way. So, I've lost my train of thoughts. Yes.
So when you talked about general expected SARSA, you mentioned how the target policy and the behavior policy have to be under certain constraints in order to converge.
Yes.
And so when you say SARSA here, does that have any sort of restrictions on the behavior policy? Because when you introduced it, you made it sound a little bit like it's just a policy evaluation.
Yes, I'm sure the SARSA can be considered as, one scheme is to have SARSA as a policy evaluation, right? And then you could view it as more of a TD version of learning of the action values. And then you can do policy improvement based on the values that you have learned from SARSA. So
then are you saying general expected SARSA is the generalized version of SARSA with the added constraint of some specific type of behavior?
I'm saying it is more general. I'm saying it's more flexible than SARSA.
But you can also have SARSA with the condition of having a policy that is greedy in the limit.
Yes, that's right.
So
but then you're changing, it doesn't have the separation between, it doesn't have the notion of a target policy in that sense, right, SARSA? Because SARSA is, you have to, it's evaluating the same policy that you're following. So there is no, if you're making a greedy, you're essentially your behavior is also have to be greedy. Right? Because if you're evaluating a more greedier policy, your behavior also has to be changed accordingly. Okay.
So maybe I'm showing enough knowledge here, but is there any reason I could not use this in like DQN and replace the Qlearning with DQN with expected SARSA?
Replace DQN with expected SARSA?
Replace the Qlearning with DQN with expected SARSA. Does that make sense? Is it possible?
Replace DQN with this.
Well, replace the
target.
Q in DQN.
The Q in DQN.
Yeah.
And
Yes.
SARSA N.
It's possible.
Possible. I mean, there's other considerations in terms of the networks itself, right? So I don't know that yet. But yes.
Very interesting talk as a framework for a very studying algorithm. If you're going to, I know this was purely a theoretical investigation. If you're going to give empirical results to try to convince people to use it, how would you go about setting up that experiment? What would you actually show to show the benefits of this?
Ah, okay. That's a very good question. So there is one problem, like a very small domain, and it's a simulation domain. It's called the Wendy-Greer world. And I think I'm going to go to the next slides just to go into like, not really an answer, but maybe so there's some histories of this. So in Van Sidgen, 2009 paper, he actually did an investigation, empirical and theoretical investigation of expected SARSA, but he actually used it not quite in the general expected SARSA form. He just fixed the policy and he treated it as an on-policy algorithm. And so in there is actually an example of Wendy-Greer world. He says, okay, well, expected SARSA actually does not outperform Qlearning. But it does not outperform Qlearning, and with a very stochastic environment. The more,
But in his paper he did.
no, in there is a like figure 5 or figure 6. I can't remember. He said like it performed quite similarly. You could look at the result. There's no statistical significance there. But so in that sense, I could maybe try it with changing policy, maybe make it greedier, you know, as in the limit, and try it out with this problem. Yeah, I think figure 6 or something. I can't remember.
That's for your next talk? That would be your next talk?
Perhaps.
It's like slightly above, but it is close.
Yeah, it is very close, but I can't remember which figure. But it was figure 5 or figure 6. I can't remember. Yeah, so there's no what he did in that paper, he focused on trying to compare SARSA with expected SARSA, and he's saying that SARSA actually, you know, expected SARSA has less variance, so it's outperforming SARSA. The focus of the paper was more comparing SARSA with expected SARSA rather than Qlearning and expected SARSA. So which I think, you know, we need to be a little bit more encompassing and compare all three algorithms in some sense. Yeah, especially if we could, you know, change the target now. Yes.
So the way that SARSA is usually used, as far as I understand, is that you have some epsilon greedy policy, and SARSA is doing a policy evaluation bit. But then isn't that also a behavior policy that's changing over time in the target?
So that's where the grayness comes in. It's a little hard to think about it if you have like a softmax or epsilon greedy policy in that sense, because yes, every time you're changing, you know, your action values, at the same time the next iteration, your policy is kind of changing with respect to it. So in that sense, maybe there's like a little bit of off policiness to it. I'm not entirely sure how to capture that behavior. I'm not sure how to think about it right now. But one scheme of using policy SARSA is to use it as a policy evaluation algorithm, and then you do an improvement step based on the value that it's learned. So that was actually suggested by in the Precup's paper, Precup and Perkins and Precup's paper. It is actually mentioned in this paper. So that scheme was that particular form of formulating SARSA is used in this. No, not in this one. Sorry. Ooh, I don't think I have that reference. Shoot, sorry. But yeah, it was used in one of the, it's natural to use it that way, so. Yes?
I feel like generalize the expected SARSA as a framework that unifies policy evaluation and control in one framework.
Mm-hmm.
And it's specifically for a simulation-based method. means you don't have the model. So I can't imagine any other method, like value-based method, that is out of this framework. Do you think I'm right, or do you have some concrete example of something that is not generalized expected SARSA? I mean, value-based algorithm.
So, sorry, I didn't quite understand your question. You have to say it again. Sorry.
So I feel like generalized expected SARSA is a framework that unifies policy evaluation and control in one, in one framework. And I can't imagine any value-based, simulation-based method that is out of this framework. Am I wrong, or am I right?
I'm not making that strong of a statement, though. I'm thinking that it's going to behave somewhere between a policy iteration and value iteration, but I'm not sure how to capture that yet, like how to characterize it to say for sure it is actually generalizing these two things. And this is just two methods, right? Because what if we don't want to actually be stuck with these two modes of learning in MDP? You know, maybe general expected SARSA will offer us even more flexibility in that respect, because the pi-t can be quite arbitrary, right? Well, maybe not arbitrary in some sense right now, right?
Yeah,
could be.
It's so universal, and I
Yeah.
can't find any example that is out of this scope.
Yeah. Thank you.